Section 7.1, the log function defined as an integral. So in this section we are going to see some examples where we need to find the integration of you know which will be eventually the log function. So we know that the derivative of log function ln is 1 over u times du over dx. So we already know about this, and these are the some relation or some properties of ln function, and by using that we can say that okay, the integration of 1 over t is actually ln of t, and if you want to find out that integration from 1 to x, it will be actually ln of x. So that's how we can define natural logarithmic function for any variable x, and we can find out the value of that natural logarithmic function at e by just replacing that x by e in previous definition, and that is eventually 1. Now, using those two facts, we can say that if u is a differentiable function that is never 0, then integration of 1 over u is actually ln of absolute value of u plus some constant. These are some properties of this is the relation between exponential function and natural logarithmic function e and ln of ln, because they are inverse of each other. Their composition, these are the compositions, should be same as input. So the derivative of exponential function e is actually e to the power u times the derivative of u with respect to x. So by using that fact, we can find out the integration of that exponential function e to the power u is e to the power u plus some constant. These are some properties of exponential function, and then this is the relation between exponential and then logarithmic function with the base a. And if you want to find out the derivative of e to the power u, by using the chain rule with respect to x, it will be a to the power u times ln of a times du over dx. So if we want to go opposite, if you want to find out the integration of a to the power u where u is the variable, then by using the substitution rule, this is what you are going to find: au over ln of a plus c. So think about, let's say you want to find out the integration of 2 to the power x dx, then by using this formula it would be 2 to the power x over ln of 2 plus constant. Okay, so for any positive number a which is not equal to 1, the log of logarithm of x with base a, this is the notation, and its inverse is a to the power x, we know that, and that's their relation because they are their composition, because they are inverse of each other, their composition would be same as input. So these are some rules of log function: product rule, quotient rule, reciprocal rule, and power rule. They all are very simple basic rule from college algebra. You can review them, and that's derivative of log base a of u with respect to x. And now let's see example. I'm going to do two example in this section. This is just using integration rule here we discussed for finding the integration. Before finding the integration, you might have to use substitution. So for example, here as is, it looks difficult, so I'm going to do what I'm going to do is I'm going to say, okay, let's say u equal the value on the exponent of e, which is 3 times the square root of r. By making that substitution, I can find out the du equal 3 times the derivative of square root of r, which is 1 over square root of r times dr. Okay, so as you can see that du equal 3 times dr over square root of r. There is a dr over square root of r, but there is no 3, so we're going to just divide both sides by 3. By doing that, I can just replace this dr by square root of r by du over 3. So now this problem now become e to the power u, and this dr over square root of r can be replaced by du over 3. I can bring this 1 over 3 outside, and now the problem becomes finding the integration of EU with respect to U, and that's where we can use that's where we can use this formula. The derivative of U is EU plus constant. Okay, but we don't keep our answer as is because we need to you know put that value of U back. So our answer should be in terms of original variable for this indefinite integral. So that would be e to the power 3 times the square root of r plus constant. So that's our final answer. Sometimes the problem might be definite integral. So as you can see that the problem is 11 times e to the power v cosine, and then there is a parenthesis e to the power v. So what we can do is, before doing the problem, we can just keep this 11 outside. So ln pi over 6 ln pi over 2 e to the power v cosine e to the power v. As you can see that this e to the power v is repeated, and if we can find out the integration of e to the power v cosine e to the power v dv, then we can just plug that value back here and use the fundamental theorem. So for this, let's say u equal e to the power v, so then du equal e to the power v dv. So this problem becomes because this e to the power v is u, right? But here is the e to the power v and dv together, that will be du. So cosine u times du. This ev is replaced by u, and this ev times dv is replaced by du. Now the integration of cosine is sine u. Okay, so eventually we need to find the answer in terms of v, so it would be sine e to the power v. So this is the integration, but this is the integration for indefinite integral. So what we do, instead of putting plus c here, we're just going to put that sine ev and then plug the value of limit of integration, which is from ln pi over 6 to ln pi over 2. So just put sine e ln pi over 2 for the v minus sine e ln pi over 6. Since we know e and ln, they are inverse of each other, so instead of e ln pi over 2, eventually it will be just sine pi over 2 minus it will be sine pi over 6, which is, we know the value of sine pi over 2 is 1 and value of sine pi over 6 is 1 over 2. So eventually it's 1 times 1/2, which is 11 over 2. So that's our final answer.